Hey everyone. So we're always talking about what AI can do, right? It writes poems, it discovers new medicines, it's pretty wild. But today we're going to pop the hood and look at what AI actually is, on a physical level. We're talking about the silicon, the actual processors, the specialized hardware brains that make this whole revolution even possible.
And just so you know, all the awesome info we're about to get into comes from a super detailed and comprehensive report put together by the pros over at Virtualization Options LLC. They really did the deep dive on this stuff.
Okay, so let's get right into it. You see AI create this incredible art from just a few words, or translate languages on the fly. But if you ever really stopped and wondered, what kind of engine is under the hood making all that happen? I'll give you a hint, it's not the same thing that's running your spreadsheets.
And here's the absolute key to understanding all of this. Modern AI is all about the math, a truly staggering amount of it. Training a big AI model isn't like solving one super complex problem. Nope. It's more like solving trillions of pretty simple problems, but they all have to be solved at the same time. This takes a colossal, almost ridiculous amount of raw computation.
So let's start at the beginning with a processor we all know, the CPU, the Central Processing Unit. It's the original brain in pretty much every computer, the foundation that all of modern computing was built on.
So think of a CPU like a brilliant, world-class head chef. This chef is a total genius. You can give them any recipe, no matter how complicated, a fancy French sauce, an elaborate dessert, and they can nail it. They are masters of complexity. But, and this is crucial, they handle these tasks one after another, sequentially.
And, even among these master chefs, there are different styles. Some are all about those complex single-step recipes, while others are built to just blaze through a ton of simple steps with incredible speed. But no matter how they do it, they're all focused on finishing one main dish at a time.
And this is exactly where our brilliant head chef just hits a wall with AI. See, AI isn't one complex recipe. It's like asking that one chef to prepare a really simple appetizer, but for an entire stadium of 10,000 people all at once. It doesn't matter how amazing that chef is, their one-at-a-time nature creates an impossible bottleneck.
So, if the master chef can't handle the massive party, what do? You don't need a smarter chef, you need way more cooks. And that brings us to the GPU, the game-changing solution that really unlocked modern AI.
Right, so in comes the GPU, the Graphics Processing Unit. Now, these were originally made for video games, to render millions of pixels on your screen all at the same time. Then, some very clever researchers had an aha moment. Instead of one genius head chef, a GPU is like an army of 1,000 line cooks. Now, each cook might only know how to do one simple thing, like chop carrots. But, and here's the magic, all 1,000 of them can chop carrots at the exact same time. That massive parallelism was the perfect, and I mean perfect, fit for AI.
So, seriously, the next time you type a silly prompt into an AI and it spits out a photorealistic image of an astronaut riding a horse, you can thank the GPU. It's that huge army of cores all working together, each one tackling a tiny piece of the puzzle that makes it possible to create something so complex, so incredibly fast.
But of course, the story doesn't end there. The evolution continued. What if you don't need an army of cooks that can make any dish? What if your restaurant only makes pizzas, and you need to make them faster and more efficiently than anyone else on the planet? Well, that's when you call in the specialists.
We're talking about chips like Google's TPU or the NPUs you find in your smartphone. These are a special breed called ASICs, application-specific integrated circuits. Forget the chef analogy for a second. This is a custom-built, fully automated pizza machine. It can't make you a salad, it can't grill you a steak, but it can churn out perfect pizzas with absolutely mind-bending speed and efficiency, using way less power than a whole kitchen staff.
And believe me, you use this tech every single day without even thinking about it. You know when you open your phone's camera and it instantly finds all the faces in the shot to get the focus just right? That's not happening on some server miles away. That's a tiny, super efficient NPU, a little pizza machine, running right there on your device. It's what makes that feature instant, private, and it saves your battery life. So as we start to pull all this together, you can see it's not really about which processor is best. It's more about having a whole toolbox full of AI hardware and knowing exactly the right tool to grab for the specific job you're trying to do. This table right here just sums it all up beautifully. You've got the CPU, your versatile head chef, running the whole show, handling all the general purpose stuff. Then you've got the GPU, your army of cooks, doing the incredibly heavy lifting of training these giant AI models. And finally, the TPU or NPU, your automated pizza machine, built to run those trained models with maximum speed and efficiency.
So, look, if you walk away with just 3 things from all this, make it these. The CPU is your versatile all-arounder for everyday computing. The GPU is the parallel powerhouse that completely unlocked the potential of deep learning. And TPUs and NPUs are the hyper-efficient specialists that are now putting that AI power right in our hands, on our devices.
Which leaves us with a pretty fascinating question to think about, doesn't it? As AI gets woven deeper and deeper into the fabric of our world, our cars, our homes, our appliances, are we heading toward a future where every single device will need its own little specialized AI brain just to function? Something to chew on. Thanks for joining me for this explainer.